What if you fell into a black hole? The question alone sends shivers down the spine, stirring images of darkness, mystery, and the unknown. Black holes are among the most mysterious and powerful objects in the universe. They don't just attract matter, they consume it. Not even light can escape their pull. So imagine for a moment that you're an astronaut, drifting peacefully in space, when all of a sudden you realize something's wrong. Your spaceship begins to move, slowly at first, but then faster and faster. Ahead of you is a region of space that appears empty, pitch black. Yet it's surrounded by a glowing disk of superheated gas spiraling around it like water down a cosmic drain. You are now heading directly toward a black hole. As you move closer, strange things begin to happen. The stars behind you start to distort and stretch. Time itself begins to slow down. From the perspective of someone watching from a distance, your approach toward the black hole would look like you refreezing in time right at the edge. They would never actually see you cross the event horizon, the boundary beyond which nothing can escape. But from your perspective inside the spaceship, time seems to be flowing normally. You feel no different, at least not yet. You are about to cross one of the most mysterious thresholds in the cosmos. Once you pass the event horizon, there's no turning back. This point marks the boundary where the escape velocity exceeds the speed of light. Even if you fired the most powerful rocket engines known to humankind, you wouldn't be able to resist the black hole's gravity. Now, you are truly falling into the unknown. As you get closer to the center, you begin to feel the effects of what physicists call tidal forces. These are not the gentle tides you see at the beach, but a devastating difference in gravitational pull between your head and your feet. Your feet are closer to the black hole, so they are being pulled much more strongly than your head. Your body begins to stretch. Scientists have a name for this process. It's called spaghettification. It's exactly what it sounds like. You are being stretched into a long, thin strand of atoms. It sounds horrifying, but oddly enough, some physicists believe you might not even feel it, because your brain would shut down due to the extreme forces before your body experiences the full effect. Still, let's say you somehow remain conscious. As you continue to fall inward, things become even more bizarre, according to general relativity. At the very center of a black hole lies what is known as a singularity, a point of infinite density, where space and time cease to exist in any form we can understand. At this point, the known laws of physics collapse. No one knows for sure what happens there. Some theories suggest you would be crushed into oblivion. Others believe something even stranger might occur. What if a black hole is not an ending but a beginning, a gateway to somewhere else? There are speculative theories in modern physics that suggest black holes could be portals to other universes or wormholes that connect different parts of space-time. Imagine falling into a black hole, and instead of being destroyed, you're transported across the cosmos, or even into a parallel universe with different laws of nature. It sounds like science fiction, but serious scientists have proposed such possibilities. The idea is that black holes might be more than just cosmic death traps. They could be engines of rebirth, shaping the structure of the universe on the grandest scales. But even if they aren't portals, they are still deeply fascinating. Inside a black hole, time and space switch roles. Time becomes a direction you move toward, just like we move through space. That means the future becomes unavoidable. No matter what you do, you are always moving toward the singularity. It's as if you were sliding down an hourglass and there's no way to stop. But the weirdness doesn't end there. According to quantum physics, information can never truly be destroyed. But if something falls into a black hole, what happens to the information about its particles? Is it lost forever? This is known as the black hole information paradox. Stephen Hawking once believed that information was lost in black holes, but later reversed his position, suggesting that it might be encoded in the radiation that slowly leaks out of black holes over time. This radiation is called Hawking radiation, and it's the key to understanding whether black holes truly destroy what falls into them, or if they preserve information in some hidden way. There's also the holographic principle, mind-bending idea that suggests everything that falls into a black hole gets recorded on its surface. The event horizon, much like a hologram, if true. It means the three-dimensional contents of a black hole are encoded in 2 dimensions, like a cosmic data backup. In this sense, falling into a black hole might not erase your existence entirely. A copy of your information could still exist on the boundary of the black hole, silently etched into the fabric of space-time. It's a haunting, yet beautiful idea. Now imagine this. As you fall deeper, the laws of physics continue to warp. Gravity bends light into wild spirals, time begins to feel distorted, and your perception of reality itself starts to dissolve. If you had sensors or a camera, it might record things no human eye has ever seen: streams of light trapped in orbit, echoes of past events, the twisted remnants of stars long gone. Your fall becomes a journey through the strangest regions of the universe. It's lonely. You're completely cut off from the rest of the cosmos. But at the same time, you are now experiencing something no human ever has: a direct encounter with the edge of physics, a place where the known universe ends and the unknown begins. There is awe in the terror, wonder in the silence. You are no longer a person. You are part of the black hole, part of a cosmic story that has fascinated humanity for generations. Scientists are still struggling to unite general relativity, which governs gravity in the large-scale universe, with quantum mechanics, which governs the subatomic world. Black holes sit at the intersection of these two realms. They may hold the secret to a theory of everything, a single framework that explains all the forces in the universe. If we can understand what happens inside a black hole, we might unlock the greatest mystery in all of science. Until then, we are left with questions. What is the fate of matter and energy inside a black hole? Could consciousness survive in some form? Is death really the end, or just a transition to something else? These questions are not just scientific, they are deeply philosophical. They force us to confront our own place in the universe. We are tiny creatures, living on a small planet, orbiting an ordinary star in an average galaxy, yet capable of imagining what it would be like to fall into a black hole. That in itself is astonishing. Black holes remind us how small we are, but also how big our curiosity can be. They challenge our understanding, stretch our imagination, and invite us to explore the furthest boundaries of what is possible. So what happens if you fall into a black hole? Maybe you die. Maybe you dissolve. Maybe you become part of something greater. Maybe your story ends, or maybe it continues in a form we can't yet comprehend. One thing is certain: black holes are not just places of destruction. They are portals into the heart of cosmic mystery. And as long as we look up at the night sky and wonder, we will continue to dream, to ask questions, and to seek the truth hidden in the darkness.